this video, we're going to learn how to create a scatter plot visualization as part of an HTDAP program. We will start with the beginning of a program that we designed in previous videos. I will keep the planning steps and make systematic changes to these steps where necessary so that our program can create a scatter plot. A scatter plot plots one variable on the x-axis and another on the y-axis. This can help us see a relationship between the two variables. For this example, we'll plot births and deaths in BC from 1975 to 2012, and one dot will be plotted for each year. Step 1b needs to be updated as we need to add our scatter plot as a possible program output and choose it as our goal. So our goal is to plot a scatter plot of births and deaths in BC from 1975 to 2012. It's no longer framed as a question, but it is our goal for our program design. In step 1c, I need to update my example. Previously, when our programs produced a non-visual answer, we could write our example in the form of an expect, which was sufficient to show what type and form of answer we expected our program to output. When our program will create a visualization, like our scatter plot, we want to write an expect and draw an example of what our program will produce. I like to hand draw the examples, although you could use a drawing program on your computer if you prefer. Once you've hand drawn the example, you can take a picture of it and then insert the image into your Markdown cell using the Edit menu, Insert Image option. The purpose of the hand-drawn example is to think about what we want the graph to look like. We are not trying to draw the exact output. In other words, you should not worry about finding all the exact data points and drawing them. Instead, focus on what each axis will represent and what a rough shape of an output graph might be. We also need to update our example that is in the form of an expect. The input is the same, we will still pass in the CSV file, but our output has changed. Previously, we expected the value 2000 to be returned when we were trying to solve a different problem. Now we're creating a scatter plot, and all of our plotting functions will return none. So I need to change my expect so that it expects the value none. Now let's move to step 2b. The data definitions that we built in the previous example do not include births and deaths, so we need to update them. As a quick reminder of what we're starting with, we have a compound to store a year's population change, and then a list of these population changes. We need to update the population change compound to include births and deaths, and we'll work systematically through the steps of the How to Design Data Definitions recipe to make this change. First, we'll change the data type definition to include births and deaths, their types, and their range. I'll add births as an int and deaths as an int. And then I expect those to be non-negative integers. So I'll copy the range from total population, which was also for non-negative integers. Next, we need to update the interpretation to include births and deaths. To update the examples, I've looked at the information in the CSV file and have updated examples to copy and paste in. So these examples will be updated to include the births and deaths information for the corresponding years, which is 1975, 1976, 2010, 2011, and 2012. Finally, we need to update the template. Nothing needs to change in our list type. Our list type refers to population change and is a list of population change, but the only changes we needed to make were to the compound. Since we updated our data definitions, our read function for step 2b also needs a slight update. We now need to read in the births from column 5 and the deaths from column 6 and parse them both as integers before we create our new population change data point. I'm going to space this out a little bit differently, as our one line of code would have gotten too long. Double check that my parentheses are lined up, and they are. Now let's run this, and our tests are passing.